Welcome back. This is the session on Java input-output programming. On input-output devices, we know that Java is a platform-independent language. There are a number of input-output devices in the real world. The input devices could be something like the keyboard, the mouse. It could also be a network connection. The output devices could be your screen, like you're seeing this video, the printer. It could be a file system, your memory, could be your pen drive or your hard disk, or it could also be a network connection. Now, we have different input-output devices and different operating systems. And different input-output devices behave differently in different operating systems. For example, if you have a Linux system, though you have a computer monitor which will display your computer screen, which will serve as the display for your computer screen, the device driver for your Linux operating system is different than the device driver for your Windows operating system. The device driver is that system software that translates the display so that you can see in your visual display. For example, the screen display device driver for a Windows system is different than the driver for the Linux systems. But Java holds the promise of write once, run anywhere. That is, if you run your program in a Windows operating system and if you run the same program in a Linux operating system, whatever output is printed in the Windows environment, the same output will be printed in the Linux environment, regardless of the display device or the device driver. This is possible because Java provides us with a beautiful abstraction called streams. And there are two types of streams, input streams and output streams. And Java encourages us to program in terms of streams. The underlying difference between the operating system and the device, input or output device, is handled by the JVM or the Java Virtual Machine. So we the programmers are left to focus only on the application and not on the machine level differences. Thus, when you have a program, it will print the same output on Windows, it will also print the same output on any other operating system. So we have predictable behavior on all operating systems. And this is how Java has kept its promise of write once, run anywhere. So what is a stream? A stream is an abstraction representing an input or an output devices. An abstraction is like a black box. What is inside the black box? We really do not know. It is best left to itself. So any complexity that is hidden is called an abstraction. The universe is an abstraction for us. We do not completely understand the universe and the Milky Way. Similarly, any complexity which is hidden for us, the programmers, we call it as an abstraction. In Java, streams are an abstraction. And Java streams handle all the finer details of the various input and output devices, freeing us, the programmer, to concentrate on the real application. And you can think of a stream in the literal sense as flow of data. Thus we have input streams and output streams. So, to summarize, a stream is an abstraction. It is a complexity which is hidden from us by the JVM. The stream sits in front of the device and you program to the stream. And this stream translates into the native call of the underlying operating system to interact with the input and output devices. This is how Java programs follow the paradigm write once, run anywhere. So let us look at file streams. A file input stream represents an abstraction used to read a file, and a file output stream represents an abstraction to write to a file. Remember, we said an abstraction is a black box. It is something which is used to hide complexity from us, the application developers. So we have the file input stream and the file output stream. Here is an example of how to read a file and then write to a file. We first declare the file input stream and the file output stream, and then to the constructor we pass in the name of the file to read from and the file where we want to copy to and the file name where we want to copy to. Thus we have the variables fin equal to new file input stream and FOUT equal to new file output stream. Once the file input stream and file output streams are initialized, we start reading from the file input stream using the read method. The read method reads 1 byte at a time, and that is copied into the variable called I. And once we have read the byte, we write it into the file output stream using the write method. Read returns an int value and write takes an int value. Write of I will write the write of I will write the byte we read from the read call. We do this continuously until I equal to we do this continuously until I is not equal to -1. -1 denotes the end of the file. So this is a simple program that will allow us to copy a file. The file input stream class has a method called read. This will read the file input stream class has a method called read. This will read the file 1 byte at a time. The file input stream class has a method called read. This will read the file 1 byte at a time. The read method returns the byte as an int value. The end of the file is understood to be reached when the read method returns a value of -1. So we keep on reading 1 byte at a time, and that value is read to the So we keep on reading 1 byte at a time, and that read value is written to the file output stream. This continues until end of the file is reached. An end of the file is denoted. An end of the file is specified when the read method returns -1. Now we said the file input stream and the file output streams are an abstraction. Whatever be the underlying operating system, if the file system is a FAT file system, a file allocation table, or an NTFS file system, network file system, the above program is guaranteed to read a file and to copy a file. Whatever be the underlying operating system and the file structure, whether it is file allocation table or network file system NTFS or FAT32, this program is guaranteed to read a file and to write to a file. This is how the file input stream and the file output stream provide us an abstraction over the various file system organizations which may vary between different operating systems. Thus, Java's promise of write once, run anywhere is indeed true. Important note here, all file handles should be closed in the finally block. Remember, we should follow this structure whenever we are dealing with external resources. A file system is an external resource. It belongs to the operating system and we are getting a handle to that resource using the fin and FOUT variables. And we should always close the file input stream, output stream, or whatever external resources that we acquire in the finally method. This is a good programming practice which we need to constantly follow. Let's move on to byte array streams. In network communications, data is generally transmitted as an array of bytes and not a single byte at a time. Java provides us with an API for byte array input output, and it is called the byte array input stream and the byte array output stream. The byte array output stream has methods to write the contents of the array into a file system with one effort instead of writing 1 byte at a time. In the previous example where we read the byte from the file input stream and wrote to the file output stream 1 byte at a time. If we use the byte array output stream, we can write the contents of the entire byte array into the file in a single operation. Here is an example. We have the string, and that string is converted into a byte array using the getBytes method. We create a new byte array input stream. we create a new byte array input stream as shown by the variable BAIN, and then we also create a new byte array output stream. And to the byte array output stream, we write the contents of the entire byte array which we generated. Now we create a new file output stream, and on the byte array output stream we call the write to method and pass in the output stream. So what we have done here is we have first created a byte array output stream, written the contents of the byte array to the byte array output stream, and then written the contents of whatever is the byte array output stream to the file using the write to method. So byte array streams are extremely helpful in network communications, which we will see later in the coming lessons. Okay, time for us to look at a quick demo. Let me bring up the sample code. The sample code which I have downloaded from the portal is stored here. So let me copy this, open up my command prompt, and then I change to that folder. Okay, and then Java C star.java. I compile all the classes in this folder first. Okay, so they are compiled. Let us look at the source code. Let's look at the copy file first. The copy file has a main method which is the entry point for the program, and it expects two arguments: the name of the file to copy and where you want the copy to be stored. We create a new file input stream and a new file output stream, and we get the handles FIN, FOUT, and then we keep on reading one byte at a time from the file input stream, and whatever we read from the file input stream we write to the file output stream, and this continues until I is -1. The read method on the file input stream will return -1 when the end of the file is reached. So this is a simple program to copy a file from a source to a destination. Let us look at a simple variant of this program called the display file. The display file is similar to the copy file. We have a file input stream where we read the file, and whatever we read we print it to the console. So display file is just like your type command in Windows or your cat command in Linux. So these are two programs on the file streams. The demo for the byte array streams, what you do is we have a main method again, and we create a byte array. We create a new byte array output stream, and then the contents of the byte array is written to the byte array output stream using the write method. So the byte array output stream now has the bytes: the quick brown fox jumped over the lazy dog. We have a string here, and the string is converted into a byte array. Then we create a new byte array output stream and write the byte array to the byte array output stream. Once this is done, we create a new file output stream, and the entire contents of the byte array output stream, which internally contains the byte array, is written to the output stream using the single method in one operation using the write to method. And like a good programmer, we have a try, catch, and a finally block where we close all the external resources. So let us get back to our learning.